Okay, so let's take a look at this statistics question. We are doing a hypothesis test where the population standard deviation is unknown. A sample of 39 cans of soda have a mean volume of 12.11 ounces with a sample standard deviation of 0.27 ounces. We want to test the claim that the mu, which is the population mean for all cans of soda, is actually greater than 12 ounces with a 0.01 significance level. So in this problem, we're going to use the t-distribution because you're going to use this distribution either when n is small, which is less than 30. So in this case, our n, the size, sample size is 39, so we're not going to say it's small. Or when the population standard deviation is unknown, which is what we have in this problem. We only have the sample standard deviation at 0.27, so we're going to have to use the t-distribution. Okay, so the t-statistic is equal to x bar minus mu over the sample standard deviation over the square root of n. So here we're going to use the sample standard deviation to approximate the actual standard deviation. Normally in the z statistic, this would be the population standard deviation, which we don't know that. It's unknown in this problem. All right, so in this problem, x bar is the average, 12.11, minus the mean. Okay, so this is a hypothesis test. Okay, so HA, the alternative hypothesis, we're trying to show that mu is greater than 12. Okay, we're trying to, mu. Okay, we're trying to show the mu is greater than 12. The alternative hypothesis would be that the mean actually is actually 12. It's not greater than 12. So we'll say mu equals 12. Okay, so this is what we have to prove. Okay, so we're going to assume the mean actually would be 12 otherwise. Divided by 0.27 over the square root of 39. Okay, and when you calculate this, you're going to get 2.544. Okay, this is the t-statistic that we get here. Okay, so we need to prove with a 1% significance level that this value is actually significant. So let's draw a t-distribution. Okay. Okay, here's the t-distribution. So this is t. Okay, so we're going to say the reject region is going to be 1% significance level. So let's write it here. Okay, this is going to be 0.01, which means there's 99% probability on the left of this tail here. Okay, so this is just a right tail test. We're just trying to test whether the mean is greater than 12. We don't have to concern ourselves with the chances that it could be less than 12, less than this. Something smaller. Okay. Okay, so now using the t-distribution, where there's 99% on the left and 1% on the right, this is the t-critical value. Okay, it comes on the t-table, it comes out to be 2.429. Okay, the t critical value here, which has 1% greater than that, it means that we're willing to say that probably the mean on the population is actually, with 99% chance, is 12. But we're willing to say there's a 1% chance that if you get a t statistic that's equal to this value or even bigger, we'll say there's a 1% chance that could have happened. And if it happens, if you get a t critical that large, we'll say, you know what? The population mean is actually really bigger than 12. We're going to say this probably is what really happened. So this is the cutoff point here that tells you whether or not this 1% chance actually happened. And if you get a t statistic that's less than this value, and will be in this region, it means it's probably the means actually was really 12. Okay, that's what it's telling you. So since our 2.544 maybe is somewhere in this reject region, so this region here is the reject region. Okay, and our value is, say here, somewhere here, 2.544. Okay, so therefore we can say that we are going to reject, okay, we're going to reject HO. And we're going to say there is enough evidence to claim that the population mean, pop mean, is greater than 12 ounces. Okay? We actually can reject it and say there is enough evidence we can reject the population mean, say it's 12. We'll say it's more than 12. And here, there's a 1% chance that it's more than 2.429. Our value actually has something called a p-value, which means there's even, in this region here, on the right of it, there's less than a 1% chance. So this is less than 0.01. There's even a less than a 1% chance that this could have happened. So it only had to be 1%. It's less, which means we're going to claim this must have not been lucky. The sample really, which was 12.11, is actually really saying the population mean is actually more than 12. Okay, thanks for watching.